Okay, everybody, this video will discuss two things. One, it'll show you how to do the day 7 homework from Unit 3B, but also this, again, is project preview. It's not the project, but it's going to remind you, if you have not finished your project, how to do it. So the project has different numbers, different questions, but it's very, very similar to this. So for these first couple of questions, or just to give you an overview, this whole project was about optimizing the volume of a box to ship things if you worked at Amazon. So there are three different dimensions you'd start with. These are all like rectangles, option A, option B, and option C. The way you start this off, and I think once you see one, you'll kind of understand how to do the others. I'll just work with option A. For option A, the way to figure out the maximum volume and the height and whatever is you're going to go to Desmos and you're going to graph the following. So again, this is for option A. We would do y equals, and then each of these, 26 and 12, that's like a length and a width of a box. You're going to write 26 minus 2x, 12 minus 2x, and then x. And that might seem strange, but what that means is if you started with a rectangle, you would cut into the corners to fold it up into a box. And you'd have to cut on the left and right and the bottom and the top. So in both cases, you're cutting twice. That's why it's 2x. And the amount that you cut is actually the height. The height is actually x for all of these. So basically, what we have to do is graph this in Desmos, what I just highlighted, find you're going to see a curve that's a cubic function. You're going to see max come down to a min and then go up forever. So that first maximum, we're going to find the x value and the y value at that point. So let's type this into Desmos right here, see what we get, and then we'll be able to answer this first question. So if I go here, let me get rid of these old ones. See if I could just paste. All right, I can. So let's look for this. Okay, now you'll notice you don't see a whole lot here. You're going to have to definitely zoom out and search for it. And it's going to seem like it takes a while, but it won't be too bad. And there it is. So there's always, like, again, if you follow this arrow, it's going to go up to a peak, it's going to come down, and then it's going to go up forever. So you always want to find this first peak right here. Now, these decimals are going to happen. That's okay. This right here, I'd say 2.58 is the x value, 2.58. That is the height that you'd want, 2.58 inches. And the max volume would be the y value, 367.77. And that's going to be inches cubed, or cubic inches if you want to write that. So basically, for option B and option C, you're going to do the same thing. You're going to write the numbers, like 26 in this case, minus 2x, 12 minus 2x, and x, graph it, and the x value and y value at the first maximum you see are this height and maximum volume. So that's how you would then do option B and option C, just with these numbers. Okay, so I'm going to just keep doing option A. So using option A, it says you are trying to pack cans of soup. So you're basically going to be putting cans, which have a smaller volume, into a box with this larger volume. Now it says right here, how many cans of soup could you fit into the box from option A? Well, first of all, we have to talk about finding the volume of a single can. And the volume of a can, which is going to be a cylinder, is the formula pi times r squared times the height, or h. So what we need to do, and the good news is for numbers 4, number 5, and number 6, it's the same can volume. So you're going to have different volumes of boxes, but you're going to have the same can volume. So let's find this. Pi times r squared times h. That's like saying pi, or 3.14 if you need to just estimate it. R squared, well, it says the diameter of the can is 3 inches. And if you remember, diameter is the whole distance across a circle. So the radius is only 1.5. It's half that. We need to square that. and then do times the height of 4 inches. So this right here is going to tell us the volume of a can in this case. Now, you could just go to Desmos if you're already using it and just type that in. So you could just do 3.14 or pi times 1.5 squared times 4. And it tells you right here, 28.27. So 28.27, and again, this is inches cubed or cubic inches. That is the volume of the can. Now, what's cool about that is you're going to use that volume of a can in part number 4, number 5, and number 6. How you do these questions now, numbers 4, 5, and 6. The whole point of this is that if you have a big shape, like a box, and you're filling it with smaller shapes, like a can, you're always going to put the volume of the box divided by the volume of the can. So basically, you're going to take your answer from up here, 367.77. Oh, that looks cute. 367.77 divided by 28.27. And that's going to tell you the number of cans. So big volume divided by small volume will tell you how many cans you could fit into this. So we're going to go back to Desmos, 367.77. 367.77 divided by 28 point, I believe it was 27. Oh, there we go. And it says 13.009. So in this case, you'd actually round down. You can't put like a fraction of a can in there. So we'd say 13 cans can fit in this box, if that's the only thing you were packing in there. Now, you would do the same thing for the next two questions. So whatever you found as your answer for volume for option B, you would do that number divided by 28.27. And whatever you find for option C, that number divided by 28.27 for number 6. Okay, so, sorry about that. A similar idea is going to happen here, because now it says we're going to talk about packing tissue boxes, not cans. Well, a tissue box, it says, is a cube with a side length of 2.5. Well, any rectangular prism or cube has a volume that's basically length times width times height. It just so happens that in the cube, they're all the same number. So you're basically doing 2.5 cubed, or 2.5 times 2.5 times 2.5. So the volume of this small tissue box that you're going to put into a larger box can be found by doing 2.5 raised to the third power. And that's 15.625. So 15.625 inches cubed is the volume of the tissue box. Now, if you followed what we did in the previous questions, what we're going to do here is take the big box volume and divide by this small volume. It's the exact same thing we did for cans. It's going to be 367.77 divided by 15.625. And that's going to tell me the number of tissue boxes I could fit. So 367.77 divided by 15.625. Now again, we're going to round down, because you can't put a half a tissue box in there. You have to leave some space for air. So 23 tissue boxes can fit. And again, I'm going to keep emphasizing this. You would do the same thing for option B and option C. You take the volume answer you found in the very beginning divided by 15.625, and the volume answer you found in the very beginning divided by 15.625. Okay, now this next part is saying someone ordered 8 cans of soup, 9 boxes of tissue. We're going to find the total volume that would take up and see if it could be fit into these options. So some of the options will work, some won't. So during this video, since I've only been doing option A, I might not be able to move on to the other parts. But if option A is the good one, then we will be able to. So one of these will work. One of these options, A, B, or C, will be big enough to fit the 8 cans of soup and 9 tissue boxes. So all you have to do here to find the total volume, it's going to be the volume of 1 can times 8 plus the volume of 1 tissue box times 9. So if you remember, cans of soup, they had a volume of 28.27. And then there's 9 tissue boxes. They had a volume of 15.625. So 8 times 28.27 plus 9 times 15.625 is 366.785. Okay? Inches cubed, or cubic inches. Now, everyone, I just so happen to have picked option A. That's the first one I picked. And option A has 367.77 as its volume. So if option A as a box has a volume of 367.77, it is just barely big enough to fit these 8 cans and 9 tissue boxes. This number here is smaller than this. So I know option A works. Option A is an option that will be able to fit everything I just asked about. So again, I'm saying option A is our answer. I luckily picked that one. You know, option B might have been too small and option C might have been too small. But again, this number here is less than 367.77. So I know that works. I can fit everything into this box. So now it moves on and says, hey, you need to have space for sealed air. Now, it says sealed air will take up 100 cubic inches. Well, I don't have enough room for 100 cubic inches. So maybe option B or option C would actually be the better choice. I was able to fit this, but just barely. So maybe option B and option C has a little bit more space, because again, if I add 100 to this, it becomes 466. And that's not going to work. So then I would have needed maybe option B or option C. But just for the sake of doing this, I wanted to show you how you would get to this point. Now, question 10, does each tissue box weighs this? How much will 9 weigh? Again, that's just multiplying. You're just doing 9 times 3.5 and getting that answer. Number 11, each can of soup weighs 410 grams. There's a conversion that happens here too, and then we kind of move on from there. So let me kind of walk you through this next part here, and hopefully, again, this helps you understand what to do for your project. So if we did this, you're going to end up with 31.5 ounces. This, saying 410 grams, and then 1 gram is equivalent to that. So pretty much, people, you would have to do 410 times 0.035 to get the number of ounces this is, and then multiply that by 8. So 1 gram is this many ounces. Since I have 410 of them, 410 times 0.035, 410 times 0.035 is 14.35. That's the number of ounces. And then 8 times 14.35 is going to equal the following. 114.8. So we have this number and this number, and it's saying how many ounces are we shipping. Well, how many ounces you're shipping, we're ignoring the cardboard weight and the sealed air pack weight. 31.5 plus 114.8 is going to equal 145 and then 146.3 ounces. Let me double check that. 31.5 plus 114.8. Yeah, 146.3. And then this very last part, it says it costs 99 cents per pound. There are 16 ounces in a pound. Whew! So we'd have to take 146.3, divide it by 16 to figure out how many pounds that is. So 146.3 divided by 16, 9.14375 pounds. And if we multiply that times 99 cents, let's see what that comes out to. So we're going to have that times 0.99. So it's going to cost $9.05 to ship. So that was a lot of different kind of ideas. I believe on the project there's a little less converting. And essentially, people, if you got a little confused starting here because I didn't tell you what option to pick, again, that comes down to you. This worked, but it couldn't fit the like little air bubbles that they ship or the bubble wrap that you ship things with. So option B and option C must also have a big enough volume that this will work. So if this question confused you, again, you need to be able to add 100 to this number and make sure it works. So basically you need to figure out which box has a volume larger than 466.785. That's really what you need to pick as your option here, A, B, or C. And then the rest of this, you don't need to worry about. The rest of this is independent of that. So number 10, 11, 12, and 13. It didn't matter what option you were picking. So I hope this gave you some insight into A, how to do this homework, which you'd only have to do options B and C. So you only have a little bit more work to go. And then for the project, for those of you that didn't do it yet, this should give you enough of a head start to help you finish that.